In example 3, we're going to graph exponential functions using a table of value. So sometimes when you're just reflecting, moving up or down, it makes it a little bit easier not to have to use that table of values and plug in all your numbers and just to use the transformations. But then if you get some more complicated ones where you're multiplying things and using these fractions that aren't quite whole numbers, it makes it a little bit more difficult to start shifting things around, and it makes it easier just to use a table of values. So that's what we're going to do here. We're going to graph this function, negative 3 times 5/3 to the x, and we're going to use the x values negative 2, negative 1, 0, 1, and 2. So let's create our table. So we have our x and our y, and the x's we want are negative 2, negative 1, 0, 1, and 2. And then what we're going to do is we're going to go ahead and plug those in. So let's start with negative 2. We would take negative 3 times 5/3, and we are raising that to the negative 2. And if we go to solve that, the first thing we have to do is we have to make that exponent, this negative 2, we have to make that a positive. So to make that a positive, that's going to make these two switch spots. So what that looks like is we get negative 3 times 3 over 5 raised to the second power. Then what we can do is we can take that exponent, this 2, and we can put it on both the 3 and the 5. So basically what we're doing is we're squaring the 3 and we're squaring the 5. So we get negative 3 times 9 over 25. And if we multiply negative 3 times 9 over 25, we get negative 27 over 5. So in my table here, I'm going to write down negative 27 over 25. And that's a 7. Then I'm going to go ahead and plug in negative 1. So I have negative 3 times 5/3 to the negative 1. And remember, to make that exponent positive, I've got to take the reciprocal. So I've got to move the 3 and the 5. So this becomes negative 3.
I'll look up the name. I'll look up
The name. Okay, sorry about the interruption. So we've got negative 3, and then we're going to take that reciprocal, so it becomes 3 over 5, and then it becomes a positive 1 exponent. Well, you don't really have to raise it to the first power because it stays the same. So basically we have negative 3 times 3/5, which is negative 9 over 5. So let's fill that in our table. We have negative 9 over 5. Then we're going to plug in 0. So we have negative 3 times 5/3, raise that to the 0 power. And anything raised to the 0 power is 1. So this part of the problem turns into just a 1. So we end up with negative 3 times 1. And negative 3 times 1 is just going to be negative 3. And then what we're going to do is plug in 1. So we have negative 3 times 5 over 3 raised to the first power. Well, 5 over 3 to the first is just 5 over 3. And if I look to multiply these, remember, this negative 3 is like negative 3 over 1. So these two are going to cancel out, and I'm left with just negative 5. So then I can fill in my table. This is going to be negative 5. And then finally, I have 2. So I'm going to take negative 3 times 5/3 to the second. And so that second, I'm going to take 5 to the second and 3 to the second. So I get negative 3 times 25 over 9. And then just like before, I can simplify this negative 3 is like negative 3 over 1. So on the diagonal here, 3 and 9, they're both divisible by 3. So I can quickly say that that's going to cancel out to a 1, and this would become a 3, and I get negative 25 over 3 for my table. Then I'm going to go ahead and graph this. So if I take a look at my function, remember I don't have any shifts up or down. So that means my asymptote, which is originally at y equals 0, is going to stay at y equals 0. And then I'm going to go ahead and I'm going to approximate some of my points. So if I approximate these, the first one that I have is negative 2, negative 27 over 5. And negative 27 over 25 is about negative 1.08. So I'm going to plot that point, -2, and then -1.08 is going to be super close to the -1. Then -9 divided by 5 is just -1.8. So -1, I'm really close to -2, but not quite there. 0, -3, that's an easy one to do. It's just right here. And then I have 1, -5. And then -25 divided by 3 would give me -8.333, repeating. So I'm going to do -8 and just a little bit past that. And then I can go and form my graph. So I'm here, and then I'm going to ride along that asymptote. Next, what I'd like you to do is to try this. So I have a function for you. I want you to fill out that table of values, and then remember, just approximate those numbers on your graph. So when you're ready, you can hit the pause button and unpause it when you're ready to check your answer. If you did try this correctly, let me fill out the table for you so you know exactly what you're doing. So with -2, you should have gotten -64 over 9, which is approximately -7.11. For -1, you should have had -8 over 3, which was approximately -2.67. When you plugged in 0, you should have gotten -1. When you plugged in 1, you should have gotten -3 over 8, which is approximately -0.0527. Oh, nope, that's not right. Sorry about that. Let's get rid of that. 3 divided by 8, it would be -0.375. And then we take a look at plugging in 2. You should have gotten -9 over 64. And -9 divided by 64 will give us approximately -0.1406. 06. And then if we go ahead and graph this, our asymptote is still at y equals 0. So make sure you have that in as a dotted line. And then just approximate your points. So -7.11, -1, and -2.6, 0, -1, 1, and then we get these decimals that are super duper close to that asymptote. So our graph goes like this. If you have questions, please let me know.